Chapter 2, Overview, changes the number of protons and the number of neutrons in the nucleus by converting one into the other. Inverse beta decay involves the capture of an electron by a nucleus. In a gamma decay, a high-energy photon leaves the nucleus and allows the nucleus to achieve a more stable, lower-energy configuration. Spontaneous fission of a large mass nucleus into smaller mass products is also a form of radioactivity. Expansion of the universe. 4. The universe was created about 15 billion years ago in an event called the Big Bang. Around a microsecond after the Big Bang, the universe was populated predominantly by quarks and gluons. As the universe expanded, the temperature dropped. Eventually the universe cooled enough to allow quarks and gluons to condense into nucleons, which subsequently formed hydrogen and helium. Interstellar space is still filled with remnants of this primordial hydrogen and helium. Eventually, density inhomogeneities allowed gravitational interactions to form great clouds of hydrogen. Because the clouds had local inhomogeneities, they gave rise to stars, which collected into galaxies. The universe has continued to expand and cool since the Big Bang, and has a present temperature of only 2.7 Kelvin K, after the hydrogen and helium created in the Big Bang condensed into stars. Nuclear reactions at the cores of massive stars created more massive nuclei up to iron in a series of nuclear reactions. Higher mass nuclei were created at the end of the star's life in supernovae explosions. These elements were scattered into space where they later combined with interstellar gas and produced new stars and their planets. Earth and all its occupants, animate and inanimate, are the products of these nuclear astrophysical processes. Phases of nuclear matter. 5. One speaks of water existing in 3 states or phases: solid, liquid, and gas. Known to us simply as ice, water, and steam. Temperature and pressure determine the phase of water molecules. Similarly, protons and neutrons exhibit different phases depending on the local nuclear temperature and density. Normal nuclei appear to be in the liquid phase. Different regions of nuclear matter include neutron stars, the early universe, a nucleon gas, or a quark-gluon plasma. Scientists study these phases by colliding beams of accelerated particles to produce extreme conditions. At this time, the quark-gluon plasma has not been identified in any experiment. Unstable nuclei. 6. Although the chart of the nuclides includes about 2,500 different nuclides, current models predict that at least 4,000 more could be discovered. The proton and neutron drip lines define where nuclei with extreme ratios of neutrons to protons (N/Z) are expected to become so unstable that the nuclear forces will no longer allow them to form. Scientists are pushing towards making nuclei at both the proton and neutron drip lines as well as new elements at the high mass end of the chart of the nuclides. Element 118, yet,